this week, but so 8.9. So what did we say? Let's just kind of go slow here, but we said they gave us the bearing at 4830. So we know that this is 4830. So parallel line cut, that tells us that this is 4830. So we can kind of start carving this thing up a little bit. Highlighted in green is what we're looking for, right? Because we want to find what's the bearing of this line. What do we have? What is that angle? So what did they give us here? Well, we know we've got the 4830 on the inside, and we've got the whole angle at 102.11, right? So little quick math here to find that inside 102.11. We take away the 4830, so we found that 53.41 is that inside angle. Kind of see how we got that? Just kind of cutting this up. I mean, that's essentially what we're doing is cutting this up. Because the 102.11 is on the inside, so simply 53.41 is our end product. Does everybody kind of see that? See how we got it? Shakes the heads. If you don't, just holler and just don't. Because what we're trying to do, right? We want to try to find all 5. That's our first thing. Is we got to find all 5 of the bearings around the shape. So I'm just going to look at a couple of these now because I want to show you guys a second method after we go this. So, and this is, like I said, this is considered like dissecting. You know, when we jump over to this point here, what do we know? We've got this interior angle of the traverse of 104.42. And what did we find? We found the 53.41. That's the bearing angle. So we know that this top side here is 53.41. So what are we looking for? We've got this leg of the traverse. We've got to find this angle here, right? So again, what's highlighted in green. So what did I do to take a look at this? Well, I said, what is this total? The whole red to go from one side of the axis. How many degrees is all this? Total. 180. If I needed to know what was the total to get from here all the way around the circle to here, it's 180 degrees, right? So what do I know inside this thing? Well, if I have 180, if I take away the 53.41 and I take away the 104.42, I can find what I'm looking for, right? You guys see that? I can find what's in the green here because this is what we need for that next bearing. So that's all we did. 180 degrees, let's take away the 53.41, take away the 104.42, the resultant 21 degrees, 37 minutes, so that's that little interior angle, bang, we got it. So that becomes our 21.37. So again, this is methodology based right now. It's just understanding that we kind of just have to look at what's given, those interior angles, what do we know, or what have we calculated, and then just doing some subtraction to find what we're missing. All right, you get the gist? I think that I know whether or not I pushed the homework date back to Monday, give everybody a chance. But I want to show you guys, show you what I think is an easier method, because there are 2 methods to everything, and I don't want everybody to think, well, this one way that we're doing it, Bob's way is the right way, or Bob's way is the only way. There's 2 different ways to do this. So, so let's look at this. We're going to do this a different way. So this would be what we would call dissecting. This is looking at a single point, trying to look at everything that's engaged and involved in this. We're going to do a different way. And we're going to use, in this case, forward and backward azimuths. Now we were talking about forward azimuths and backward azimuths last time, right? So if we have an axis, and we have from point A, B, and we have this as our A to B, so let's just say this is north, I don't know, 29 degrees, 17 minutes east. So we know this angle, 29, 17, right? So our forward azimuth is going to be 29 degrees, 17 minutes. And F is just forward AZ. So that's the component. This is an azimuth in this direction. The term we're going to kind of use today is a back azimuth. Now a back azimuth still runs on this same line. It's still coming off the point. The only difference is what? It's going in the opposite direction. What do we know about this? How many degrees is that? 180, right? 180. So the back azimuth is going to just be its partner, but 180 degrees to the other side. So in this case here, all we've got to do is what? Add 180 to that. 180, and that is going to be 209. 209, 17 minutes. The back azimuth. We are going to be going back and forth. We're going to be using a forward azimuth and a back azimuth to simplify this whole process of finding the missing bearings of this. Grab a pencil, grab a straight edge, and what I'd like you to do on your sketches is do this. On each of the legs of the traverse, just stretch out arrows off of each of the points like this. And we're going to look at, let's do 8, 9. What was the homework was what? 8, 9 counterclockwise? Is that what I said?
Yeah.
8, 9 counterclockwise. Let's do 8, 9 clockwise. So let's just do this as 8.9 clockwise. And make sure I get this. What we're doing right now is drawing what's going to end up becoming our forward azimuths and our backward azimuths. We are not going to have to go through that process of dissecting each of these little points, of cutting the points up and trying to determine what's on the inside. We're going to simplify. And the reason I went through it last week the way that I did in detail, it's just getting your brain thinking about orientation and axes and norths and easts. When we start working with the traverses in the field, when we start working with the data collectors, what we're trying to get to is understanding coordinates. Coordinates are the points where these actually are in space, where we can define a northing and an easting or an X and a Y to each of our points in a traverse. That's how the data collector thinks. So we're at the base level right now, just understanding how this stuff all connects together. The bearing, let's see, so for 8, 9, what's the bearing? It gave us A to B is what? North, 4830. North, 4830 east. Now grab your crib sheets from last week, this one here. This will be the crib sheet that you want to have with you for the rest of the term, working these classes. You want to have this with the final, just in case Bob happens to have a problem like this. After we've been doing it for 3 weeks, I think you could expect to see something later on. This is our kind of crib sheet. And what I want to look at is, and if you don't have it handy, I can make you another copy. These two formulas right down here, clockwise and counterclockwise. These will be the formulas we are going to use to solve these problems. The way these work is we can use the back azimuth and the forward azimuth and the interior angle kind of interchangeably. We're going to do this in real time in application. Let's look at this formula right here, this clockwise. So put this on the top of the sheet here. So clockwise, if we're going to work clockwise, and that's what we're going to do with this, go clockwise. I'm just going to put the formula right in the middle here. We are going to say the back azimuth minus the interior angle equals the forward azimuth. Because we're working in the clockwise direction. So this formula kind of is our key. We're going to apply this at each of the points. So how do we do that? Let's work through, we're going to work through this whole traverse here. And it's going to go quick. I think that's what you're going to find is there's a method to how the flow of this goes. It works quick. It's a lot easier than what we did last week in dissecting angles. Our forward azimuth, so let's start at A to B, forward azimuth. We know that this forward azimuth is what? 48 degrees, 30 minutes forward AZ. So on the bottom of the sheet, let's start a running tabulation down here. I'm going to write down here 48 degrees, 30 minutes east. And this is the forward AZ. Now, the formula says if we know the back azimuth of a line, oh, let's write down the angles too. Sorry about that. Let's get these interior angles written in here too. 102.11. 104. When we apply the formula, this is finding the next leg of the traverse for us. It's giving us a formula to determine what the next forward azimuth is. When we apply this formula, it's asking for the back azimuth of a line. We need the interior angle, and it will give us the forward azimuth of the next line. So in our formula, we'll start with the forward azimuth. We got 48.30. What is its back azimuth? So the forward azimuth is this. What is the back azimuth? That's this direction here. How do we find that? What did we say we do?
Add 180.
We add 180. So let's just simply down here add 180 degrees to this because we want the back azimuth. And that gives us what? 228.30. And that is the back azimuth of the line of A to B. $228.30. So we can go ahead and let's just add that over here so we can see it. 228.30. Back azimuth. And if ever it gets where you guys can't read it, holler at me, okay? What's the formula say? The formula says if we have the back azimuth, we take away the interior angle, it'll give us the forward azimuth. Let's just do that. 228.30 is the back azimuth. Let's take away the interior angle, which is 102, 11 minutes, which is our angle. Grab your calculators. Let's run that out. What do you get? Shout at me when someone's got it here. Gabe says 126.19. You okay with that? I'm all right with it. Oops. 126.19 minutes. And that is now the forward azimuth of B to C. On the screen there. 126.19. We can just run up here now. This is the forward azimuth of this is now 126. 19 minutes. Forward AZ. Now, in the old method, I'm just going to kind of flip some sheets here. Now let's go back to what we had to do last time. This was quite a bit of work, right? Quite a bit of work to dissect this angle to find the bearing. We just did it in a quick, simple math step. A little easier. Yes? It is a little easier. We can now add that. What is our back azimuth? So 126.19. Let's keep going around. We're going to keep working around. We need the back azimuth to use the formula for the next leg. So how do we find that? What is the back azimuth of 126.19? What do we do? We add 180. Add 180. Do the same thing. Let's add 180 to get the back azimuth of this screen here. Let's add 180. You'll notice in your calculator the number's already kind of there waiting for you, which is nice. So let's add 180 degrees. What do you get?
206.
306.19. That is now the back azimuth of BC. We'll go ahead and throw that up here, 306.19. So we want to get from now C to D. So we're now working this way, C to D. What's the formula say to do? Let's just follow it. Back azimuth, which we have, right? Back azimuth, 306.19, minus this interior angle. Subtract 104.42. That's our angle. What do we get? Somebody shout it out when you got it. Chris, you got to punch it up. 201.37. 201.37. I like it. 201.37. And that is what now? That's the forward azimuth of C to D. We can put that right here. 201. You guys can see the pattern now? This is really just tabularly doing the same process at each of the legs of the traverse. Everybody okay so far? How we doing? Shakes of heads, we getting it? You kind of seeing it? Okay, what do we do? Let's keep going. Now, and one thing you're going to notice too here. So we have a forward azimuth. We can get a bearing with that, right? If we have the forward azimuth of this, we'll be able to get the bearing for the line. Correct? Because we'll be able to refer back to what? We can refer back to this. Where if we know the azimuth and what quadrant it's in, we can convert that azimuth to the bearing. So we'll always have that ability with this forward azimuth. We can just use the table, there's the formula, find the bearing. We have this forward azimuth, we'll be able to find the bearing. So let's keep going with our pattern. So forward azimuth of CD. What is the back azimuth? What do we do? Add 180. Let's see what happens when we add 180 to this. So 201.37 plus 180. What do you get? 381. 381. 381.37. And that's the back azimuth. All right, does that look a little weird? 381, we're bigger than 360, it's bigger. It's still okay. We can still use the number. We can use this. Even though 381 is bigger than 360, we can still use this as a back azimuth. We can still use this numerical. What's another way that we could find a back azimuth of this? What else could we do with this 201.37? We added it. Could we subtract it if we wanted to? We could. If we took away 180 to get back over to here, it would give us an angle, right? It would give us that forward azimuth. So essentially we're adding 180, we're just ending up with a bigger number. You'll see how the math works. It's okay. There's a reason that it's okay. So let's just start a new column over here. I'm just going to move this number up here. I'm going to say 381. I'm running out of room here. So we have this back azimuth here of 381. Back azimuth. Let's keep follow our process. Let's keep going. What do we do? 381. Back azimuth, let's follow the formula. Back azimuth minus interior angle, so we're going now from D to E. So let's subtract this 113. Punch it in there, or what do you get? Shout it out when you got it. Brian, get you set up here. Right, we're working on 8.9. 8.9. You're welcome. Who's got it?
268.32.
Chris says 268.32. I like it. Oops. Minutes and what? That is now our forward azimuth, right? Of D to E. So we can label that up, 268. Forward AZ. Everybody see how holler? Everybody okay so far? You guys seen it? Is it all right? Cool. Crystal, you good? Manny, Logan, you guys good? Okay. Let's keep going. We need the back azimuth of D to E. We got to find this, right? What do? Let's just add 180. All right, our numbers are getting big, right? Let's see what happens here. If we add 180. $448.32. Back azimuth D to E. So just write this down here. 448.32 minutes. So this is a huge angle, right? Way bigger than 360. What if I took 360 degrees away from it? Let's just do that just for the sake of. If I took away 360 degrees minus 360, I'm going to get something that looks a little more reasonable, right? 88 degrees, 32 minutes. That looks a little more reasonable, right, for what we're used to seeing. If we were to put an axis through D here, D, this would be tipping in this direction, 88 degrees. That's kind of what we're used to seeing, right? Because that would be. This is like a regular. We could picture this being 88 degrees. If this was our line here. This being this. 88. What did I say it was? 88.32. I mean, that's kind of like what we're used to seeing. But just by adding 360 degrees to it, it's keeping the number big, and maybe that's one of the points here. It's keeping this 448 big enough that when we subtract the angles, they kind of work. Because what would happen if we had 8832, if we use this for our back azimuth, what's the next thing we got to do in the formula? Let's go to the formula again. Back azimuth minus the interior angle here. Interior angle is what, 118.34? That's the interior angle. What would happen if we use this as the angle we're used to seeing? If this was 88.32 and we had to subtract 118.34, what happens? We get something negative, right? It's not going to work. That's the reason we're leaving some of these back azimuths bigger than 360, because it helps the flow of the math. If we change this back azimuth here and made it this smaller 88, the smaller version of 88, that negative is going to kind of mess us up. So that's why it's okay that we leave this bigger. You can leave it bigger than 360, it'll work. So punch that up real quick. 44, 448, 32. And if I take away 118, who's got it? Forward azimuth of E-Day. I got 329.58. Yvette, so you shake your head there. That's good. 329.58. Let's do that. 58 minutes. So we can label that one up, 329.58. We're on the last leg here. Back azimuth. We could do two things with this. We could add 180 and get an even bigger number. In this case, we could probably subtract 180 because it's the same, right? The forward azimuth and the back azimuth, it doesn't really care. It's just 180 degrees opposite of whatever the azimuth that we started with. So in this case here, let's subtract it. Let's subtract it. I'm going to take 180 away. That's 180. 149.58. Okay. Let's use the formula one last time, and if everything works, we should be able to see a check that comes out of this. Back azimuth of E to A minus the interior angle, 101.28. Run that out. What do you get? $48.30. Remaining, see Crystal shaking her head. 48.30. 48 degrees. 30 minutes. That's the forward azimuth of A to B. Checks out, right? The other way. We made it all the way around the traverse. We finished at A to B. Forward azimuth 48.30. 48.30. 48.30. That's what we started with. So, simpler, probably a lot simpler. This would be those that like to solve puzzles and look at angles and axes and try to play with all this stuff. This is use a formula and plug and chug. I wanted to show you that last week. By the way, hi. How are you? We're just looking at, we're going through 8.9, the homework. We're doing one homework. Plugging and chugging and following the formula, I think, is a lot easier. Crystal, yes?
We just did the classifies and we possessed.
Exactly, right.
I was looking at the numbers.
Uh-huh. So if we think about counterclockwise and clockwise, it's the direction that we're going around. We're going to follow the same methodology. So let's look back on our crib sheets. Counterclockwise and clockwise. The basis of the formula is still the same. It's what are we doing with the interior angle. The methodology is still the same. So if we solve this for clockwise, we're going to use the back azimuth minus the interior angle. If we went in the other direction, all that changes is what we're doing with the interior angle. So we can solve this for counterclockwise, which is what was in the homework. We're going the other direction. So this is the clockwise formula here. That works with this. The only change you have to make is if we said the problem goes counterclockwise, you're just going to flip the sign of this. You're still going to go through the same methodology. What will happen with that if 4830 was this? This is no longer a forward azimuth now. Whoops, sorry about that. This is now going to be our azimuth, right? Our forward azimuth. So we've got to do a little bit of work with the bearing to figure out what this is, because now we're going to be going this way. We're going to be going in this direction here. So we'll want this as the forward azimuth to start in the back. So the numbers are going to look the same. The method of calculation is going to look the same. It's just which of the two formulas are you applying. That's the only difference between those two. Okay?
So if we did clockwise, would we still add the 180?
You will still add the 180. Converting each of whatever your forwards and your backwards are, you're still going to be using 180 degrees. We just, and Jose brings up a good point. We just kind of worked through one sample problem, and in each of these we said we're adding 180, we're adding 180, we're adding 180. Essentially all you're doing is changing this by 180 degrees, and you're changing this to its complement 180 degrees. We found what? There was one of these where we thought subtracting 180 was the right thing to do to make the numbers work. So of the things that you kind of have to take a look at, this might not be just plug it in and use the plus sign everywhere Bob used the plus sign. You kind of have to look to see how the math is going to work between your forward, your backward, and that interior angle. So does that answer your question? Pretty much it's pretty safe to add 180. If you get a weird number, you might have to subtract it. Okay? Let's do this. Catch a breather. We'll come back. We're going to work 8.10. We're going to do 8.10. You guys can team up. You can do it on your own. We're going to do 8.10 so everybody gets a chance to just run through this quickly. And then we're going to jump into the table. Then we'll try to solve for the traverse. So let's catch a break here, okay? 10 minutes. We'll come back.